A piecewise defined function, or a hybrid function, which is what we would commonly refer to it in class, is a function with a different rule for different subsets of the function's domain. So what we're saying is that you can have different equations, all represented using one function, just with smaller domains. Please just note that these functions do not need to join up or connect, but they cannot overlap. So on the x-axis, your graphs cannot at any point overlap, as this would, I suppose, ruin the idea of it being a function. So we have an example here of 5i, which is sketch the graph of the following function and state the domain and range. The first step when doing this is to identify the points where your graph will change. So for instance, in this particular case, we'd be looking at the points -3 and 3, because those are the points where we go from one one equation to the next equation. So if we substitute in x equals -3 into either of these two equations, we'd get out the result of 0. And then if we do the likewise, but for x equals 3 for these two equations, we'd get out the result of, again, x equals to 0. So we're going to plot those 2 points, indicating that those are our endpoints for each of our functions. We're now up to graphing the 3 individual equations over their specified domains. So I'm going to start with our linear functions of x plus 3 and x minus 3. X plus 3 is a function that has a y-intercept of 3, and the issue with this is that within our domain that y-intercept actually doesn't hit. I'm going to use a dotted line to represent it. This dotted line is one that I will remove after having graphed this line. So it goes through that y-intercept, it goes through the point that we already identified, at which point our graph actually exists. So we draw a solid line for anything less than -3. I'm going to do the same thing for x minus 3. So -3 would be the y-intercept, and I'll use that to get my shape for my graph. You could substitute in any value that satisfies the domain. So you could substitute for this first equation, x equals -4, for instance, and you would get out a point of -1. When you actually calculate this, and you could use that as your second point and graph your line there. That's perfectly acceptable. Don't leave in the dotted lines if you do use this method, so remove those from your graph. The last part of this function is to graph the x squared minus 9 portion between -3 and 3. X squared minus 9 is a quadratic that's been moved down 9 places. So we have a turning point at 9, and we know that it goes through at -3 and 3. So if we just join that up using a quadratic shape, a hyperbola shape, we have successfully graphed our function. So the actual question states, sketch the graph of the function and state the domain and range. So I've graphed f of x, and my domain of f is all real values, and my range of f is all real values. Please don't fall into the trap of thinking that my range is from -9 upwards. Recall that this arrow, which is pointing downwards, will continue to infinity, so we're talking all real values for this function.